new content. We're just going to do a recap of what we did last week. So we just started off by talking about machine learning, what it is, some cool facts about the growth of the field and stuff, and then classic terms. Okay, we can ignore that. Okay, yeah. So yeah, the big thing was working with data and the functions that we use. So yeah, pandas was the library that we use for most of our data cleaning, data processing, and yeah, taking in stuff. Yeah, how to create a data frame. Yeah, just taking in different values, CDs versus data frames, so just like one column, that's a table, stuff like that. And then next, yeah, there's some basic functions and properties that we can use with pandas and like data sets. Yeah, locating files using iloc and lock, and the differences between them. One is index-based, one is name-based. Just so we remember that. Yeah. So mapping was another thing. So if we want to change values from one thing to another, we can use the map function and use the lambda function to replace everything in order within a column. And yeah. Group by, sort by, just by the name, we're just going to group them based on the population field. And then count for each value. Yeah. Basic data cleaning, missing data, so fill a name versus just replacing all the values that we don't have in your data set, but you still want to work with the data set. So you use fill a name and other functions like rename, concat, and join to join. Yeah. So for this week, we're going to move towards data visualization. So now after cleaning all your data sets, you want to actually show or like present what you found, which you do using like some functions and like maps and some graphs. So we're going to talk about that today. And yeah, let's get started.
So hi everybody. Can you hear me at the back? It's topic for today, data visualization. So I'm pretty sure till now you guys would have seen anything about data visualization in like Excel or even anywhere in the news. The basic idea, like why we do data visualization, like as you can see in the Excel sheet, you can't really like make any conclusive inference about anything like when you see data like that. That's why we do data visualization, so that in terms of graphs, it's much more visible if it's instead of straight up numbers. Now, like for example, in the heat map, you can clearly see that the regions that are like more important have a higher, like are darker. That's pretty much, yeah, in the heat map, anything that's more darker requires more attention. That's pretty much like an idea why we do data visualization. Now the thing is that when we do data visualization, we should first look at whatever data types we have. There's essentially two types of data that we work with. It's like continuous data and categorical data. Continuous data is anything like stock prices, height, weight, and categorical is just like how you guys are in different majors, your specialists, anything of that sort, like I said, the different kind of sports. So let's first of all let's just look at how to see all this in like the Jupyter notebook. So is everybody comfortable working with Colab now? Okay. Just pull up your Colab. Just make an empty Colab. And just load this data set. Run this.
So yeah, just run that code.
But let's just look at our data set like beforehand.
So what's the function that we use to print out a few values of our data set? Anyone? Yeah? Not it? Okay.
So as you can see, like in our data set, we have a bunch of like numerical data as well as categorical data. This is kind of like exam score is like the because the predictions we are concerned, this week we won't be doing any predictions, but if we were, exam score would be the variable we would be predicting. So based on like, for example, the attendance the student had, parent involvement, sleep hours, the most important part study, you'll be predicting exam score. Now I'll introduce one more function. I don't think this was done like last week. But in case to get an overview of like all the different variables, you can run B type, data type. You go student performance like the data set, then dot B type. It's going to return the data type of every variable in this set. This is a series. So R study type obviously is an integer, attendance is again an integer. Just to like I think this was done last week, but how do you see the like how do you count the how many times the same value occurs in a series? Like what's the function? To get the count of how many times a particular variable occurs. Like how many times does integer occur again and again, or how many times does object occur again? This was from last week. This is value count. Like the function it is called value count, and it just goes over the series and counts the number of times a particular value occurs. So if you run value count, you just get that there are 13 object types. An object is just these ones. Like strings are usually encoded as objects. Like that's how pandas prefer to work. And integers are just like these ones, 3, 4, or like the exam score variables. So by using this, you can like kind of get an idea what kind of variables you are working with, and like how many of them are there, how many of them are categorical, how many of them are continuous. So things like as Chris said before, last week we looked at how to clean our data, but there was one thing that was missing. It's called outliers. So essentially, if you have a bunch of data points, some of the data points are just like this. It's mostly an error. For example, in the data frame, like the custom data frame, if you see the very last value, it's like social media usage. It's like 50 at like the age 75 in the data frame. Like that does not make sense for me. So this is like one way to like, get rid of values like this. Right now it's a small data frame. You can look at it and identify which one is an outlier. But if you have like a million observations, then you can't look at every single value and like try to get rid of it. The reason why we remove outliers is usually, like I said, it's mostly an error. That's why we have to remove. There's one case where you would, like this outlier would make sense. And the example for that, it's like, I don't know if you guys saw it, but like where games stop, the peak, like it's essentially an outlier because it was a very level stop. But the peak is an outlier, but we do have to give it like special importance. So in this case, we would not remove that outlier. any value closer to like x that has a greater y value, that just means it's highly probable, okay, more probable than the other. For example, 1 has a certain probability here, 2 has a certain probability here, but it's less than what 1 has. That's all this distribution means. So whenever we get like the series that I have, like the series we had in the previous slide, what you can do is literally just try to figure out what the probabilities of every single value occurring are, and anything that lies like farther here, that has like less value, that's probably an outlier. Because if you have a value like, for example, in your data set plus 1 plus 1.5, they all have a certain probability of occurring, but if you have a value like plus 10, that's like less probable that it occurred, and it's more likely that it was an error. So, like the Z-score thing, all that does is that for the entire series that we have, for every individual value, it's going to give a Z-score, which will be something like plus 1, plus 1.5. The general standard that we use is that it's anything that is farther than plus 3 or farther than minus 3, like it's away from the center. So it's either like plus 5 somewhere here or minus 3 somewhere that is something like here. It's probably an error, and that's what we call an outlier. Now, in the case like you have to remove the outlier or no, that you will have to decide after you see the outlier. So, like in the example that I gave for stock prices, we would not remove the outlier. Like that's the most important thing, like the stock went up. And another thing, like another example would be something like credit card like fraud. Because as you say, you've been making like $100 transactions every week or something like that, you suddenly get like $5,000. Like that's probably an outlier. That is an outlier, but it's something like you would have to be concerned about. I'm giving this from the, like the bank's perspective. It's not obviously like you see a 5,000 transaction, you know that you didn't make it. But from the bank's perspective, they would only know if they look at your data. If this guy has been making $100 and suddenly $5,000, that's an outlier. So then they would be concerned. That part is called anomaly detection. We look at it in the coming weeks probably. But here, like in the data set that we just loaded, like the toy data set, let's look how to calculate the Z-score. In Python, there's a library called SciPy that you just can load.
So basically, the idea of the Z-score is to get a sense of how far you are from the average of your data set. Right? So the X bar in this is the average. The X is the value that you're trying to, like, basically, consider, and SX is the standard deviation. So you're going to go farther away. So if your X is X bar plus S, which means you would put X bar plus S in this place, minus X bar, so that's just S. S over SX is just plus 1, so you get plus 1 here. That's kind of the sense we're doing it. So if you have X bar plus 2S, that would be X bar plus 2S minus X bar, so that's just 2S over SX, which is just 2, right? So that's your Z-score in that sense. So that's just a kind of an idea of how far you are going away from your average. And the further away you are, the less probable that value of X is in your data set. Cool?
So, do you guys know how to run like dot mean from last time? You see how you can run like dot standard deviation as well, the denominator? You try calculating the, for this column, social media users, calculate the Z-score for it. Like for the whole entire. Drop this code out. And if you run like my data, and then you just retrieve the social media user. Try calculating the Z-score for all these manually. Like the code I sent, it used the library, but I think you can do this manually from like last week. Try doing that for the social media users, get the mean, get the standard deviation, and create a new column that gives the Z score for each of the values. That's the formula for getting the Z.
So what's a possible method of converting this formula into a function on Python? You have a mean, you have a standard deviation, and a division.
Or dot stdy, like the bracket. Dot std. Get the mean, get the standard deviation, and then standardize each value. So that's what this entire thing is called. I think this one is called normalization. Normalize each value.
Let's take 3 minutes for that, and then we'll move on.
So does anybody want to give their solution?
Yeah.
My data, because I can see through it. Is equal to, in parentheses, my data column social media, my data dot social media social underscore media dot usage minus my data of social underscore media underscore usage dot mean parentheses. That's my assumption to the column. And then you close the parentheses and then you divide by my underscore data social media usage dot std. The standard deviation. So this is my data.
Yeah. So if you guys see, in this my data one, you see how this like 75 and like 50, the one that I said was an outlier, it actually has a higher Z value. So if I go, if you see on the slide, it's going to lie somewhere right here. The other values 0 0.2, 0 0.5, all of them are going to lie closer to it. But this 1.8 is going to lie much farther. That's why if you were running like an outlier test, this would be considered an outlier. Like essentially I can just bump up the value so that it crosses 3. But like I think you guys get the point. Anything that is much farther from the mean, like this would be the mean. Anything that's farther from the mean might like it should be removed. It's way farther. That's basically like from last week we didn't cover. That's what we call like an outlier. And it's where it's used in pre-processing to clean the data. But sometimes you just have an error and you gotta remove it. In this case, yes. Because what happens is when you subtract from the mean, everything gets forced to zero. So the data might actually lie like somewhere here, like the curve would be here. But when you subtract, it would be pushed here. And then when you what do you call it, divide, then it would be like standardized. So the data is like spread out. The divide would be centered to, the standard deviation would be 1. So literally you divide by the standard. The variance would be 1. Yeah, because it would be going towards minus.
So does anyone have any questions regarding how we got this least force problem? We can go over that one more time. Anyone? You can just raise your hand. Okay. It's a bit challenging. Okay.
Yeah. So the Z force thing, you can also do it using like
A map function.
yeah, you can do a dot apply function.
Yeah, map.
Yeah, you can use like any way. Like this one, this code is like much cleaner simply because we had a smaller function. Other than that, last week we used a couple of other methods like dot apply, dot map. If you have a bigger function, like you have like 4 lines of code, instead of doing them on like a single line, make a separate function and then apply it to the whatever column you want. That's how you write like longer code instead of doing that. But for this one is perfect. It works perfectly. And you can also use a like library to do this. That's what we had in the lab. Yeah. So you just use the SciPy library to get stats. From stats you get the Z score. It gets applied to like this column. But this one is like for the data set that we loaded, like the Kaggle data set. So if you guys want, you can use this. I'll print the code. But what this essentially does, for the R studied column in the data set, like the data set we loaded from Kaggle, is going to remove anything that has an absolute value of zero. Absolute value greater than 3. So if it lies like +3 and after it or -3 That's how you would run this function. So just to explain, like here, it creates the same thing you guys did, but you did it like manually. Here I use like the library to run it on the column. And like outlier, like the definition of an outlier is simply something that has an absolute value greater than 3. You get the outlier and then you just like remove it like using just query it to be honest. That's how easy it is. My data and then if everybody familiar with this indexing, it's my data and then you have the filter inside from last week. So I'll just do an example instead of so like here this yeah, that's pretty much what you do. Yes, this one.
Yeah.
The one from the library. Probably has to be something with shipping. It is so like to a more like in the floating point, it is so like more decimal points, it's more precise.
So let's say I have like some adjustment. I haven't looked at the function that we use in the library, but it should be very similar in the values from the library. And the ones that we calculated manually doing the minus mean and dividing by standard value.
That is it. Okay, so we look at the thing you said to visualize data. Like now we'll actually get into data visualization. And another like seeing the outliers is another key factor for doing data visualization. So let's just see how to plot this. Are you guys familiar with the scatter plot? It's just like if you take the x-axis, y-axis, you just plot every single data point. That's how scatter plot is. Now for that one, we use a library called matplotlib. That's like the main topic of today. Yeah, this one. So it's like in your Jupyter notebook. Import matplotlib. So
All right, let's continue.
So for the second half, essentially it's just a bunch of plots, but I'm pretty sure you've seen these plots before. First one is just line chart. All it does is like the individual data points that we saw, it's just going to pass a line through it. It's not like the regression line, just a normal line. I'm pretty sure the syntax is similar. Can be used to generally this is used for like time series data. So you just have all the like closing values of let's just say a stock and you just see how it varies. And the next one, I'll just do this one later. Well, you're probably familiar with the histogram. So yeah, this is from the data set you loaded from Kaggle. It's like R study, but you are plotting it based on like the motivation level. Like I don't think you guys saw the data set, but it's showing it to you. trying to get the distribution that we saw in the Z-score thing. Because we don't have a lot of like, what do you call data points for this? We only have, I believe, 6,000 something data points. So that's why the histogram looks like that. But we are mostly interested in something like this, like the distribution of data. So if you look at the distribution, you find that for exam score, there's a peak at like 65 here. Regardless of this, speaking at something like here, like 66, 67. So that's basically the whole idea of like data visualization. You want to see how the spread looks like, how the mean looks like. This is like what the histogram plot is. Then what I want you guys to do now is that in the data set, there's one column that has previous exam score, and there's one column that has like a current exam score. So what I want you guys to create a new column that contains the difference so that we can see the improvement. So take both of these columns and make a new column out of it, and you just like subtract them out. Show it in the Jupyter notebook. So you take this exams column and the previous course column, and you make a new column out of these that contains the increase or decrease. Do the new exam score minus the previous score. Make a new column out of it. We have this column like with the previous score, and this column with exam score. Now, how would you go about creating a third column that has like an increase or decrease? Like this, subtract them?
So we want to create a new column, call it difference, and then yeah, it should have the values of the difference between the previous scores and the exam score. So
You could just answer example and just rewrite the difference, which will qualify and equal to the performance exam score minus the performance previous score.
That'll be your one.
let's take 2 minutes for that.
This is essentially how you would do it. It becomes like a full measure. exam score minus previous score simplified into just reverse it. And you get the difference here. Now use the SNS histogram plot to plot this the difference one. Use the function the first function histogram plot to plot this new column. Make an inference. Did you guys plot it? You have your result. What can you infer about the result? What kind of distribution do you see? Is that the one we saw, like the normal distribution? Is it like that? It isn't. It's like uniform. It has uniform. Now we like think I'll plot it on this thing. Yeah. You guys see how like from say 10 to 20, I'll just put the thing. Yeah. You see how this isn't like the distribution that we saw. Like it doesn't have a single key. It has like it goes up and then it's same thing for everybody. So what do you infer from this? Like after you see this plot, like what you're supposed to infer, like understand, is that from let's say like minus 20 to minus 30, we have the same count. Like on the y-axis, just how many people had a decrease of 20 marks, 20 to 30 marks. So this count, this represents the number of people who had like a decrease of 20 to 30 marks. This one is like 10 to 20 marks a decrease because it's minus, right? We did it. So what this like plot tells you is that like you find a uniform distribution from like 10 to 20, a similar amount of people had 10 to 20 increase, a similar amount of people had like a 0 to 10 increase, similar. And what that means is you see how it's like shifted to the left. So that means like difference thing, do it on the difference column and retrieve the one who had a difference greater than 15. Try.
This is a big part about visualization. It's not just plotting these graphs, it's actually understanding what patterns we see from these graphs. So, which is what goes from what I explained, it's called inference, which is basically like you have values and you can see them on a graph, but like what does it actually mean? Like what is it telling you? Is there a trend? Is there a correlation between few fields like yes, like where a count and exam score, like what are you trying to plot against what and what do you gain from it? So once you have those, maybe you can try to predict other things based on the correlations that you see. Right? So like that's the whole point of data visualization. To see like existing patterns and like predict more based on it.
Like I already learned how